Hello guys, welcome to another session of Mate Math. Today in this video we're going to look at how we can evaluate this definite integral here using U substitution approach. This integral here is a definite integral because the limit has been given. That is what the integral which goes from 0 to 1, that is 1 over 1 plus square root of what x dx. We have to evaluate what this integral here. So as I said, you are going to use U substitution approach to evaluate this definite integral here. But how is the U substitution going to be done? Well, you can use the U substitution in two ways. You can either let the whole of 1 plus square root of x be equal to U, or let square root of x be equal to U, and then you continue from there. Any of these two substitutions that you use, you're just going to get the same answer. But mind you, because it's a definite integral, when you make the substitution, make sure you change the limit also to the other word, that is what the U word or whatever variable that you substituted this one's for. Okay, all right. So having known the approach that we are going to use, let's get started. Now let's bring this problem down here. So we are going to use U substitution approach to solve this problem. As I said earlier on, that the U substitution approach can be applied to ways. Either we let the whole of 1 plus square root of x be equal to U, or we let square root of x be equal to we let U be equal to square root of what x. Any of these two that you use, you're just going to get the same answer. But here in this video, we are just going to let U be equal to square root of what x. Okay, you can let the whole of this one be equal to U, and you still get the same answer. But here I'm just going to do, we're not going to do it that way. I'm just going to let U be equal to this one, and then work out the solution in bits. Okay, so we are going to do substitution, and we are going to let U be equal to square root of what x. So substitution. So as I said, U is equal to square root of x. Now when you make substitution, everything has to be in what the variable that you substituted the x for. Everything has to be in that variable word, and here the variable here is what U. So since we are moving from x word to U word, everything has to be in what x word. So we don't have to see the x, but we have to see the U. So we have to find what is going to replace the x in the whole the U word. What is going to replace the x in the word U word? Okay, so how are we gonna get that? Just going to differentiate it. But before we differentiate, we're just going to square both sides so that the differentiation will be easier. Okay, so let's square both sides. Now when you square this, you're just going to get U squared, and then when you square root of x, you're just going to get what x. So you're going to get U squared is equal to x. Now let's differentiate. Now when you differentiate this, we're gonna get 2u du, and when you differentiate, you are gonna get dx. So 2u du is equal to dx, or dx equal to 2u du. That this one means that when we enter the u word, we will not write this dx there. We will replace this dx with what 2u or du. And also, the limits given in the question are values of what x. We have to find the values of what those x in the u world. You know, those values are for x, not u. So to get what is going to be the value for what 0 and then 1 in the u world, we have to put them into this one, so that we will get what is going to be the variable values for what u in the u world. Okay, so here I'm just going to put x is equal to 0 into this one, and whatever we get will be for this one, and then later on we put x is equal to 1 into the same equation here, and whatever you get will be for what u. So at the end of the day, those figures that we are going to have will be for what the limit will be for what the values of what u in the u world. Okay, so let's put x equal to 0. So as I said, you're going to put this one x equal to 0 into this one here. Okay, so u is equal to square root of x. Now when you square 0, what are you going to get? Square root of 0 will give us what? 0, right? So u is equal to 0. Now the corresponding value of 0, which is what? S value in the S world, in the U world is what? The same thing as what? This 0 here. Okay, now what of 1? When we enter the U world, is going to be the value of 1 in the U world. Okay, so let's find out that one also. Let's put x equal to 1 into the same equation. So put x equal to 1. So let's put it into it. U is equal to square root of 1. Now square root of 1 will give us what? The same 1. Okay, so u is equal to 1. Good. Now this one, we didn't see any difference, just that we are lucky to, we were lucky, we just got the same values as what? The limit for what? U in the u world. But it's not always true that when you want to find the corresponding values of what x in the other variable, where you get the same thing as what was given in the question. It's not the same, but here we were lucky. I would say we were lucky that we just got the same values to be the values of u in the u world. Okay, so now that we know the values of u in the u world, and also we know what is going to replace the x, and also the substitution being made successfully, let's put them into the integrals, and then let's continue from there. Alright, so now this limit here are for what? U, and not what? X. Please take note. Here is 0 and then here is 1, but it does not mean they are values for what? X. Remember we put what was given the question, which is 0 and then 1, into the equation, which is what u is equal to square root of what? X. And then lucky for us, we had the same thing as what? 0 and then 1. So this 0 and then 1 here are limits of what? U in the u world, and not what? The x world. Okay, now let's continue. So 1 out of 1 plus u times 2u du. Alright, so when you multiply this by this, what are we going to get? Here we're just going to put these 2 at the back here, then we multiply this one by this u, and I think that will give us what? U over 1 plus u. Alright, so as I said, I'm just going to put this one at the back here. Alright, so u over 1 plus u. How are you going to integrate this one? What approach at all are you going to use? Another substitution, would it work? If this one appears to be u squared, substitution approach will work again. But since this one is not squared, when we do the substitution, It can work, but the work is going to be a little bit lengthy. But to make it very simple and short, we're not going to do another substitution. What we are going to do here is that I'm just going to manage of we're just going to try and rewrite this u here, so that we can get what is here on top here. I said we're just going to find a way to rewrite this u, so that what will be on this numerator's position will be the same thing as well what is here. Okay, so here I'm just going to add and subtract 1 from this u. When we add and then we subtract 1 from this u, it appears to be two like fractions. Why? Because u plus 1 minus 1, when we put bracket on u plus 1 is the same thing as 1 plus u, and then the minus 1, when you expand it's just going to get the same thing as u, but when we expand it, you're just going to get u plus 1 minus 1, and that when we split it into two fractions, it becomes u plus 1 over this minus 1 over this. Both of them will get the same denominator, meaning we can split it at the end of the day. Okay, so let's add and subtract 1 from this numerator here. Okay, so let's add and subtract. Good. So as I was saying, u plus 1 and then minus 1 all over 1 plus u. This one here is the same thing as this, but to be able to solve this one, we have to split it into like fractions. How are we going to do that? Because the whole of this one is having the same one denominator here, we can split it into like fraction by giving both of them the same denominator. This one has become one thing, and this one thing is being separated by this minus here. When you have something like 1 plus 1 over 2 plus 1 over 2, when the rule of like fraction says that when the denominators are the same, we just add the numerators. Okay, it becomes something like 1 plus 1 over 2. Just pick one of the denominators and then we add the numerators, and that will give us 2 over 2, and then we get it as 1. So applying the same thing here, this one here can be written as u plus 1 over 1 plus u minus 1 over 1 plus u. When we simplify it, you're just going to get the same thing as this. Okay, so here we're just going to split this one using the rule of like fraction. This one we are just reversing it. If you have something like 1 over 2 plus 1 over 2, and then you solve it, you're just going to get something like this. But in this case, it is being given in this form, so it's just a matter of taking it back, just a matter of reversing it. So we're just going to reverse it from 1 plus 1 over 2, and then you're just going to get 1 over 2 plus 1 over 2. Don't confuse yourself with this minus sign here. The most important thing is getting the fractions to be like fraction. When it is like fraction, whether it is multiplying or whether it is subtracting or adding, we just apply the same rule. Okay, so here is going to be u plus 1 over 1 plus u minus 1 over 1 plus u. Good. Now, when we simplify this one, it's just going to be the same thing as u plus 1 minus 1 all over 1 plus u. We are just having all the same denominator here. Now, don't confuse yourself with this. This one is u plus 1. This one is 1 plus u. You get the same thing as this. They are the same. Addition is commutative. Yours, you can choose to, either rearrange this one, or either rearrange this one. Anyhow you do it, or can you also maintain this one, then do your cancellation, and then you are good to go. Okay, so this thing is commutative, so we are not going to waste another time of what rearranging. Okay, so here, since this one here is the same thing as what this one here, this will cancel out with this, and it will give us what 1. But here, this one is not the same thing as what this one, but as compared to the first one, we can easily integrate this one as compared to how it was. So this will cancel out with this, and it will give us what 1. So you're just going to get 1 minus 1 out of 1 plus u. Good. So now this one is very simple to integrate as compared to the other one. So here, now let's write answer for this one here. So when we integrate 1, what are we going to get? Just going to get what u. And then when we integrate this one, what are you going to get? That is what the natural log of absolute value of what 1 plus what u. Okay, so you're just going to get 2 multiplied by u minus natural log absolute value of what 1 plus what u. Good. Now let's open the bracket. Now this one times this one give us 2u, and then this by this one give us what 2 times natural log of absolute value of what 1 plus what u. All right. Now the answer to the integral question that we are solving or evaluating in the u world is what? This one. That is the answer in the u world. But if you want to find the answer in the x world, then you have to replace u with what you substituted it for. That is, you have to replace u with what? Square root of what? X. But the question says we should what? The question made it clear that it's an what? Definite integral by giving what? The limit. So either you just end here and then sorry, either you end here and then you just put the limits into this expression, and then you just get your answer at the end of the day, or you go back to the sorry, or you go back to the x world, and then when you go back to the x world, please don't use the values of what u in the u world. No, when you go back to x world, just pick those limits that were given in what the question. Okay, but if you want to find the values, if you want to find the value in the u world, then you have to use the corresponding values you had in the u world. Okay, so here we are not going back to the else world again. We're just going to end here. We're just going to end here and then put the limit into this expression and find the value at the end of the day. So we're just going to put this limit, that is 0 and then 1, into this expression, and then we find our value at the end of the day. So with integrals, when it is a definite integrals and then you had your answer, then you just bring 2 verticals, the one on top and then one on down, then we just put this one inside, representing that you are just going to put those limits into the answer that you had to find the value. Okay, so let's write it in that form to make it familiar. All right, that is what I was talking about. Anytime you integrate any definite integral, when you get your final answer, that is how normally we will write it. That is, you just write it in this way. This one is the upper limit, and then this one is the lower limit, or this one is the upper bound minus upper bound, and then this one is the lower bound. Okay, so if you want to find the value at the end of the day, the formula is upper bound minus lower bound, or upper limit minus lower limit. That is, you first have to put the value of the upper limit into the expression, find the value, then you deduct after putting the value of lower limit into the expression. Whatever you get, just deduct it from what you had for the upper limit on. Okay, so here I'm just going to show both. You're just going to show both. So just first going to put this one into this, then we take away, then we put this one into this. So good. So when you put 1 into it, this is how it's going to be, and then also when you put 0 into it, this is how it's going to be. So the formula says upper limit minus what, lower limit. So what is the value of upper limit? That is what, 1. So this one is what reflecting the 1 being what inserted into the whole expression, and this one too reflecting what the lower limit being what inserted into the expression. Okay, so here let's simplify this to see what we are going to get. Now 2 by 1 will give us what, 2, and then 1 plus, don't worry about the absolute value, you just work it in base. Just don't get confused with the absolute value symbol. Don't confuse yourself with it. You just do what you know. At the end of the day, you're just going to get it. So 1 plus 1 will give us what, 2. So this one will give us 2 minus 2 times natural log of what, 2. Now let's come here. 2 times 0 will give us what, 0, and then here 1 plus 0 will give us what, 1, and then natural log of 1, from the laws of logarithm, natural log of 1 to any base is what, 0. So natural log of 1, you just I said don't confuse yourself with the absolute value. The value here is what, positive, so we are just okay. The absolute value simply means plus or minus, but what is here is what, positive. The values of what, the limit that we had for what, u in the u world, we had all of them to be what, positive, so there is nothing to be worried about. If you are thinking of how to deal with it, just punch it on your calculus and you get your answer at the end of the day. Okay, so this will just give us what, natural log of 1. Natural log of 1 just going to give us what, 0. Multiply by 2 will be 0, so the whole of this one will be what, 0. Okay, so what we are going to get is 2. What we are going to get is what, 2 minus 2 natural log of what, 2. Okay, because the whole of this one will give us what, 0. I said you forget about the absolute value. Okay, so that is the answer to the integral question that we are all evaluating. Okay, that is 2 minus 2 natural log of what, 2. Absolute, when you write as absolute value of 2, now the 2 is what, positive, it's not negative, so you can just take the absolute value symbol away there. You can just put bracket on it, or you can write it as what you are seeing here. Either you write it as you are seeing here, or you put bracket on this 2. Anyhow you write it, you are just good to go. Okay, or you can also choose to simplify this one further by writing as 2 minus natural log of what, 4. With natural log, this one here, well, you can bring it here and then just power this one. That will give us what, 4. Okay, so therefore integral which goes from 0 to 1, that is 1 over 1 plus square root of x dx, is equal to 2 minus 2 times natural log of 2, or 2 minus natural log of 4. Either this or this, you are just going to get the same what answer. They are all the same. Either you write your answer this way, or you choose to write your answer in what, decimal form. Nobody cares. Anyhow you leave your answer, anyhow you write your answer, you're just going to, provided your answer is what, correct, you're just going to be what, awarded with your what, marks. Okay, so either this or this, any of these two is what. But in exams, make sure you don't write it as you are seeing here. Just write one of them, either this one or this, or in decimal form. But please don't write both of them as you are seeing here, like this or what, that. Okay, just write one of them and then you are good to go. Okay, all right. That's it, guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching, and I will see you in another video.